This is section 11.2, the Law of Cosines and the area formulas. All right, so there's a thing that probably would make a lot of sense to you if you gave it a little bit of thought, that if you have three sides that you want to make a triangle with, it's certainly impossible if the two shorter sides are not long enough to create a triangle. So, for example, if this were 10 units long and this were 3 units long and this were 4 units long, the length 4 and 3 added together is 7, and in order for a triangle to exist, that sum has to be greater. The two shorter sides have to add up to something greater than the length of your longest side. So there's a statement, triangle side restriction. In any triangle, the sum of the lengths of any two sides must be greater than the length of the remaining side. Okay, so that just tells you if you're given information like that and someone says, well, solve that triangle, you need to be able to say that's impossible, okay? Because that will sometimes happen. All right, so we're going to talk now about the law of cosines, which is the other major tool used to solve triangles when they are oblique and don't fit one of the categories we've already talked about. So if we have a triangle, and let's draw this triangle so that one of the sides is on the positive x-axis, and that makes this point 0, 0, and let's say it stops right here at a0, which implies that that side is a units long, and let's call that point C, that's at 8, 0, and the point B is at 0, 0, and then we need a random third point, put it out here perhaps, and that will be point A, and we're going to need to get the coordinates of that in just a minute. So if that's A, and that's side A, well, that makes sense. They're across from each other. So this is side B, and this is side C. Okay. So if we were to look at the length of the segment that would go from point A down to the x-axis at a perpendicular, that's some y value, and if you'll recall, one of the things that was mentioned in the last section or two, I can't remember exactly when it was mentioned, is if this is angle B, then what's true about that is that the sine of B is the same thing as the sine of its supplement. And we're in degrees because we're solving triangles still. And of course that supplement is this angle right here. That's an angle inside the triangle. So, and what would that sine of B then be equal to? Which is equal to sine of 180 degrees minus B, the angle I just marked. Well, if that's a right triangle over there to the left, it's going to be opposite over hypotenuse, which is C. And so we can conclude then from this that sine of B will be y over C. using a transitive property argument. If sine of b equals the sine of its supplement, and the sine of the supplement equals y over c, then sine of b has to equal y over c. Okay? And what would the cosine of b equal? Well, the cosine of b will be, let's see, how does that? Cosine of b is the opposite of the cosine of its supplement. Okay. Now, let me think about that a second. Cosine of yeah, that's correct. It's not working out in my head for some reason, so I've got to be careful here. Oh, yes, okay. So down here is an x, and that x happens to be negative because it's to the left of the y-axis. Okay, and so that's going to equal x, which is negative, over c, adjacent over hypotenuse. And consequently, we can conclude by transitivity that the cosine of b is x over c. All right. So that means that the coordinate of point A will be, if we solve this one for y will be c sine b and x will solve to be c cosine b, making the coordinates of point A c cosine b, so it's x coordinate, comma c sine b. Okay, so now what we're going to do with that is think about the length of segment B. The length of segment B. Since we have the coordinates of the points on either end of that segment, we can use the distance formula to calculate the length of B. So that's going to be x sub 2, which is c cosine b, minus x sub 1, which is a, quantity squared, plus y sub 2, which is c sine of b, minus y sub 2, which is 0, quantity squared. Make sure your vinculum goes all the way to the end of your radicand. All right, so let's simplify this. For one thing, I want to get rid of the radical, so I'm going to square both sides, giving me b squared on the left side and the radicand on the right side. That is the thing under the radical. It's called the radicand. And I'm going to go ahead and simplify that a little bit. Anything minus 0 is just itself, so this will be c sine b quantity squared. And then doing the squaring, first of the binomial, that will be c squared cosine squared b minus 2ac cosine b plus a squared. And again, in case you have forgotten, to square a binomial where there's subtraction, you're going to get a squared the first thing squared, keep the sign minus, then 2 times the first thing A times the second thing B, plus then the square of the second item. So that's a little algebraic thing that I just used in squaring C cosine B minus A. Then the sine, C sine of B squared is C squared sine squared of B. And one other algebraic thing there is if you have a product like C times sine of B and you're squaring it, you distribute that exponent to each factor inside. So each individual factor of that product is squared. Okay. Now, let's see what we can do with this. There is a couple of terms that I want to pull together in a second. I'm going to put the a squared out in front, just being sort of alphabetical here. I put the a squared out in front, and I'm going to check these off as I deal with them, because sometimes, or I'm going to underline as I deal with them, because sometimes you kind of forget what you've already done and what's still yet to be done. So it's good to keep track. Okay. Then I have 2 things that have c squared, so I'm going to write those as c squared sine squared b plus, so we've taken care of this one now, and then c squared sine squared, oh my goodness, I wrote the other one, hold on, sort of messed up a little bit here. I wrote sine when I meant cosine, so I'm going to figure out the easiest way to fix that. There we go. So the one that I actually used first was not the one I underlined, it's this one. So, and the order in which you write them, it doesn't really matter that much. But I did want to be consistent with, I'm kind of taking account of everything I'm doing as I do it, and I kind of messed that one up. I wrote one down and underlined the other one. So now we've taken care of this one. And then finally, last thing is the minus 2ac cosine of b. All right. Now, oh, I guess I should underline that I took care of that as well. So let me do that. Took care of that. So I took care of everything on the right-hand side. I just rearranged the order in which things were written. Okay, so that makes b squared equal to a squared. And the next 2 terms have a common factor of c squared, which I will factor out, leaving sine squared b from the first of those 2 things, plus cosine squared b from the second of those 2 things, minus 2ac cosine b. And then, of course, we're going to now use an identity that says that sine squared b plus cosine squared b is equal to 1. And so c squared multiplied by 1 is simply just c squared minus 2ac cosine of b. And that is one of the forms of the law of cosines. If I had made angle A the one at the origin, it would have given me a slightly different version of this, or if I'd put C at the origin, I would have had a rearrangement of the variables. So let me give you the other 2 right here with these. So the next one that I might write is that a squared would be equal to b squared plus c squared minus 2bc cosine of a. And the last one I might write is c squared is equal to a squared plus b squared minus 2ab cosine c. Now, you really need to understand the relationship amongst those variables and looking at the triangle, because it's super easy to get caught up in memorizing this as three separate formulas. And then I come along and I call this new triangle JKL, and the memorized thing you have, which is going to involve A, B, and C, doesn't work. And that's really a bad way to learn this, is it only works if it's called the right thing. You need to really understand what's going on. So one of the things I'd like for you to look at in each of these formulas, the side over here that's by itself, the name of it, in this first case B, is the name of the angle that you're taking the cosine of. So A, side A, cosine of angle A. Side C by itself, cosine of angle C. Then, if one of the letters is used in both of those places, then you're going to use the other two sides here and here. So I've already used B, so that leaves A and C. In the second one, I've already used A, so that leaves B and C. And in the third one, I've already used C, so that leaves A and B. And then those two letters are used here and here and here. So in the first one, the A and the C are on the right side, and that product is AC in front of cosine B. And second one, B and C are on the right side. BC is multiplied by cosine of A on the right. And A and B on the right side, that's going to be a product of AB. And then it's always minus 2, the product of those two sides that you're using on the right side, cosine of the name of the angle that is the same name as the side on the other side of the equation that's all by itself. That's what you really need to learn, is that pattern. Now, one thing I think is extremely cool is if we happened to have a right triangle and I happen to call the right angle C, and I'll just call these randomly A and B. So this is side C, side A, side B. If I wanted to use the Law of Cosines, which, by the way, I'm not sure I said that that's the name of what we just did, so let me make sure that you have that. This is the Law of Cosines, 3 versions of it, but really I would just memorize one of them and make sure that you memorize it as in the way I just talked about. The letter on the left matches the letter of the angle on the right, and the other 2 letters in the triangle are used as their side lengths. So square of the other one, the second one, plus the square of the third one, minus 2 times the second one times the third one. And if you get that kind of in your head, you'll be in good shape. So that's what we call the Law of Cosines. 3 versions, and of course you have a lot more versions than that if you use different letters. And that's why I'm saying learn the relationship more than memorizing these 3 different combinations of letters. But anyway, if this happens to be a right angle, then that would make the third one, which is the one I would like to focus on, be C squared equals A squared plus B squared minus 2 times AB cosine of C, which in this particular case I'm making it a special triangle, 90 degrees for C. And what is the cosine of 90 degrees? You're right, it's 0. And so what that becomes is C squared is equal to A squared plus B squared minus 0 leaves that. And have you ever seen that before? Yeah, it's the Pythagorean Theorem, which I think is really cool. This is basically the Pythagorean Theorem for when it's not a right triangle. So there's an adjustment made with the part back here this minus 2ab cosine c, or whichever letters you're using, this part right here is an adjustment for the fact that it might not be a right triangle at the angle C, or whichever angle is in the formula you're using. And so that's sort of, it's the Pythagorean theorem with adjustment for the fact that C might not be 90 degrees. I think that's just kind of a cool little connection to something you already know. All right, so that is the law of cosines, and that's the final piece on solving triangles that are oblique. This is going to allow us to solve all of them now. Okay, so the ones we haven't addressed yet are side angle side and side side side, and those are the two that law cosines will help us with the most. All right, so I think I gave you this picture, but I'll reproduce it here. Obviously not drawn to scale. Just accept whatever measurements I give you as if they were drawn perfectly. So that's 52 degrees. Side B is 5.0. Notice there are no units for length, so we're not going to worry about units for length in our answers. This will be side A, and I'm going to tell you that C is 11. Okay? So this is angle B and angle C if you want to know. The only question we're supposed to address is finding A. And after we had A, we could probably go ahead and solve the triangle using the law of sines, because we'd have the A pair, and we could use the law of sines to find both B and C. Well, maybe. Be careful. What is the longest, and we're not actually doing this, so I kind of feel like I'm wasting time, but it's a good discussion. What is the longest side of this triangle? Let's see. So, therefore, what is the largest angle? Angle C. If you had to find C, would you be happy using the law of sines? Remember, sine inverse only gives answers from negative 90 degrees to 90 degrees. And if C is obtuse, inverse sine will not get it. So what you're going to have to realize is if you were going to solve this one completely, you would want to find B after you found side A. You'd want to find B using the law of sines, because B is definitely not obtuse because it's not the largest. And then use subtraction from 180 to find C. It may or may not be obtuse. I really don't know. What I'm saying is be careful about using the law of sines to find an angle that might be obtuse. And the only one that could be obtuse is the one opposite the longest side. So that's just a little caution I want to throw up about doing this. Now, to solve for side A, when it's side angle side, you want to find the side across from the angle that's given. The angle that's given has the same name as the side you're trying to find, which means that that's the side that's by itself. Equals. Then pick either one of those. It doesn't really matter to me, the order, because you're adding. So another side squared plus the third side squared minus 2 times the product of those two sides that you've chosen to use times the cosine of the angle that's between those two sides. So that would be 52 degrees. So how will you solve for A? Well, you'll take the square root of both sides, and since the length of a side is positive, I don't need to write plus or minus because I know that it's positive. Now, notice I'm not doing any simplifying, and in this one I probably would. If I were typing this in, I wouldn't want to type 2 times 5 times 11. I would in my head go 2 times 5 is 10, 10 times 11 is 110, and I'd type minus 110 cosine. But what I'd like for you to do is to try typing this in its more complicated form. In other words, don't simplify it in your head at all. Type what you see, because sometimes you won't be able to do arithmetic of those numbers in your head at all, because they'll be such weird numbers that there's no simplifying it without picking up your calculator anyway. So type this as you see it, because that's the most complicated version of it that you might have to type. So I want you to make sure you can get the right answer. So please pause the recording, type that in, and see what you get. You should get A is approximately equal to 8.847. I hope you were in degree mode, because 52 degrees is a degree measure. That may, if you didn't get the correct answer, that's a possible error that you may have made. Now I'd like for you to go back and type it again, but this time do the arithmetic you can do in your head. What I would type is square root of 25 plus 121 minus 110 cosine of 52 degrees. So I'm typing a lot less. And if you can do the arithmetic in your head correctly so that you're not typing as much, that's of benefit, I suppose. That's going to speed it up just slightly. But you are, of course, welcome to type it as you see it. In that calculator-ready form, you can type it just like that. Okay, so let's do an application where we use the law of cosines. So we have a surveyor who wishes to find the distance between 2 points called A and B on opposite sides of a lake. I can't remember if I put this picture in either, so I'm going to draw the essential part of it. This is the part, I guess, it kind of makes sense to me that measuring across a lake is not going to be that easy. You may not be able to get a tape measure to go from one side of the lake to the other. But let's say that you can measure the distance from A to C, and you can measure the distance from C to B. And, oops, I wrote C, meant to write B. I said B, just wrote the wrong letter. So AB is the distance you can't get with a tape measure, but you want to know how far it is. So you take a measurement. Let's see, let me read the problem. While standing at point C, the surveyor finds that AC is equal to 259 meters. So this is 259 meters. And BC is equal to 423 meters. Okay. And the angle ACB measures 132 degrees, 40 minutes. Find the distance AB. Well, if you notice, that's side angle side, and the distance from A to B, I'm going to call it little c for just a second, and I'm going to call this B, and I'm going to call this A. And of course that's angle C. And the side I want is the same name, C, as the angle that's given, so I can use the law of cosines here. So the unknown side, C, squared, is equal to one of the other sides, squared, plus the third side, squared, minus 2 times the product of those two sides I just mentioned, so they're used again, times the cosine of the angle between those two sides. Minutes. Okay, so then to solve for C, I'll take the square root of that mess. I'm writing the calculator ready form right here. This is what I was trying to say earlier. I doubt that you can square 423 in your head, and I doubt you can square 259, and I even doubt, because I can't do those in my head, so I'm kind of thinking maybe you can't either. You might do the multiplication by 2 in your head, like make it 846 2 times 423 is 846 times 259. But that product I couldn't do in my head. So the only thing I could probably do with any confidence that I wouldn't screw it up is that I would do the 2 times 423 in my head, maybe. Or I might just type it. I don't know. Sometimes I do, sometimes I don't. But certainly the rest of the arithmetic is not anything I would try to do in my head. Not like 2 times 5 times 11 in that prior example. I can do that in my head all day. This I couldn't. All right, so pause the recording and type this in and see if you get the correct answer. I got 628.101. So the distance between A and B is about 628. I want to talk a little bit about what I just did with rounding. But before I do that, am I missing anything here? Is there anything else I should put here? Yeah, the units are in meters, and that's very important. One of the things I want to say about the math that's up above this sentence is the work. And is, of course, if you're making your own picture drawing of what's going on, that's part of your work as well. So all of that's work. The answer for a word problem, I would really like it if you would write a sentence and communicate as if you were talking to a person about this problem and its solution. So what did they want to find? The distance from A to B. So the distance between A and B is about. And then, since you have the 628.101, you've made me extremely happy getting those 3 numbers after the decimal point. That makes me happy. But in your real-world answer, you might decide that rounding to the nearest meter is good enough. And I'm not going to gainsay you on that. It's just make some decision. You have the 3 decimal points to make me satisfied. So as long as you round, you could even round that to 630 meters, arguably, because it depends on what you're going to do with the information. It may be that 630 is close enough. But so for the sentence answer, you can round differently from what I've said to use as 3 numbers after the decimal. If you think it should be rounded to the nearest unit or the nearest tens or the tenths, if that makes sense to you, that should be how you measure that kind of thing, whatever that is, that's your choice, and I'm going to be happy with that, because in the work you're going to give me the 3 decimal places that I've asked you for. Okay. All right. Next example. So this one we're actually solving the entire triangle. A is given to be 42.3 degrees. Side B is 12.9 meters. And side C is 15.4 meters. All right, so drawing that, this is about 42 degrees-ish, and that's a given measurement. I'm going to call B this one. It's arbitrary, by the way. I could have picked the other one. I was just thinking about which one is longer. I want to make this one longer, just because I can. It doesn't really matter. Pick one. And this one I'll call C, which of course has to be the other measurement. And that means that this side over here, not drawn to scale by the way, I've tried to make 15.4 look longer than 12.9, but that's about as accurate as I try to be. So this will be side A that we have to find to solve the triangle. We need to know all 3 sides. Given 2, we need to find the third one. This will be called angle C, and it's to be found, and this will be called angle B, and it's to be found. And they're called that because they're across from the side that has the same name. Okay, so see what you can do with this one on your own, and pause the recording and come back and we'll see how you did. All right, so obviously we need to solve this triangle by using, because it's side angle side, the law of cosines. So let's go ahead and set that equation. The side we're solving for, a squared by itself, is equal to one of the sides that's given, squared, plus the other given side, squared, minus 2 times the product of the two given sides, times the cosine of the given angle, 42.3 degrees. Okay, so a will be the square root of that mess. And again, I'm not even going to try to do any of this arithmetic in my head. I think I'll just type it as I see it. And after typing it in a calculator, I get 10.474, which I probably should store in my calculator in case I need to use it. Kind of hope I don't need it for much, but if I do, I'll have it stored. And are we done with A? No. Gotta have the units. Meters. Okay. So, we still have to find angles B and C. And as I said earlier, we'd want to find B with the law of sines because it is simpler than the law of cosines. Because we could actually use the law of cosines to find angle C or angle B. It's just a lot more complicated than the law of sines is. So you always want to use the law of sines when you can, as opposed to the law of cosines. The only difficulty is you never want to use the law of sines to find what is probably or maybe an obtuse angle. So we would not want to use law of sines to find C, because it is the longest side, C, and that means angle C is definitely the greatest angle, so we would never want to use that law of sines to find C. Okay, so since the pair we now have is sine of our given angle divided by this stored in the number calculator, should equal the sine of B. Remember, we're going for B because it's the smaller of the two remaining angles, just in case C is obtuse, over 12.9. Okay, so we'll isolate sine of B by multiplying both sides by 12.9. And even though we're writing 10.474, we're never going to type that back in our calculator because that's erroneous. We want to use the stored value, but we're not even ready for that yet. Okay, so the angle B will be sine inverse of that mess. So when you type this in your calculator, make sure instead of typing 10.474 that you're recalling the stored number to get as much accuracy as you possibly can. And when you find B, it should be 56.018. Did I forget anything? Yes, I forgot the degree symbol. That's the unit of the angle B, so you've got to make sure you put that on there. And then the best way to find C, now that we know two angles, to find angle C, we're going to use the fact that the 3 sum to 180 degrees. So 180 degrees minus the two angles, one which was given, and the other which is probably still in your calculator. I don't think we'll need it again for anything else. I don't know if you really need to store it. It should still be there in from your last calculation. You just bring it back and use it right there. So what do we get for C? C is about 81.682 degrees. And as it turns out, that's not obtuse. And if I'd used the law of sines, I could have gotten C, but I would have been sort of wondering if maybe I had made a mistake because it might not have been correct. So I think that's better safe than sorry. At least in my mind, I much rather play the safe game in this kind of endeavor. All right, so let's see. Next example, solve triangle ABC to the nearest tenth of a degree if A is 5, B is 6, C is 9. Okay, this is side, side, side. This is the other major type of triangle, besides side angle side, for which the law of cosines is necessary. It's the only way, because we certainly don't have an angle side pair with the same name, so we can't use law of sines. We don't have any angle, so we can't figure out that the sum is 180 degrees to find anything at this stage. So law of cosines is about our only recourse. So since we're using law of cosines for sure here, I want to remind you that if you're doing cosine inverse, the range of values for cosine inverse goes from 0 to 180 degrees, which means that if there's an obtuse angle, this would definitely allow for that, and we could get an obtuse angle answer using law of cosines. So my recommendation here is that I would go for the largest angle with the law of cosines. If that's what you're doing, is finding an angle using law of cosines, find the largest one with it. So for that reason, angle C will be the largest because side C is the longest. So I'm going to put C by itself. Notice it's not now unknown. Then either side squared plus the other side squared minus 2 times the product of those two sides times the cosine of the angle. And what's the name of that angle? C, because it's got to match the name of the side on the other side by itself. So to solve for C, you first want to solve for cosine of C. So I'm going to subtract 5 squared. And again, these are numbers you might be able to simplify in your head, and that's fine. This thing I'm writing right now is in case they're weird numbers, and there's no way you're going to try to do them in your head. This is how it's going to look if you can't do the simplification in your head. Now, in order to get cosine of C by itself, the next thing I'm going to do is divide both sides by whatever is multiplied by cosine of C, namely -2 times 5 times 6. And I would like for you to do this process as if you can't do any of that arithmetic in your head, so that I want you to practice typing this. And then after you've used the cosine inverse of that whole mess without doing any simplifications, I want you to type what you see here so that I know that you're prepared for any nasty kind of number that you might be given where you couldn't do mental arithmetic. Type this in, and I want to make sure you can get the right answer when it looks like this. And then after you've done it and gotten it correct, then you might want to go back and type in what you might have done in your head. Cosine inverse of 81 minus 25 minus 36. That's not that hard. Divided by negative 60. That's not that hard. And type that in and make sure that you get that correct, as if you're doing some of the arithmetic in your head, at least when you can. Okay? So, what do you get for C? You should get 109, so it's definitely obtuse, 0.471 degrees. We'll probably need this, so go ahead and store it in the memory of your calculator. Okay. Now what? Well, now we have, we could actually find B and C using the law of cosines, but as I said, it's the most complicated of them all, so you don't want to use it really more than once in a problem if you can help it, because it's just so complicated. So instead of using law of cosines a second and third time, now that we have angle C and side C, we have a pair, and we can use that pair and the law of sines. So the sine of, what do we want to go for next? How about A? Because it doesn't matter. Sine of A over 5 would equal the sine of this stored in your calculator number. I am recording the rounded version of it, but of course that's not the entire number. It's only sort of close to correct. By making 3 decimal places, we have a lot of good digits, but still you want to get your maximum number of digits by storing in your calculator. And of course that'll be sine of C over C, which is 9. So you'll isolate the trig function, sine of A, first, by multiplying both sides by 5. And then use sine inverse to find A. Oh, and what I meant to say earlier, and I just forgot, if you had troubles with getting the 109.471, you might want to try the fact that you need to protect the numerator so that you do all of that before you divide, and you also need to protect the denominator that you do all of that before you divide. So you might need an extra set of parentheses that aren't necessary for the handwritten version of it, but the calculator version of it, those pink parentheses are actually going to be crucial for getting the right answer. Okay, so let's see, what did we get for A? 31.586 is what I get. And then, of course, once you know 2 angles, the easiest way to get the third angle is to use subtraction. So angle B will be the total of all 3, 180 degrees, minus the stored number in your calculator minus your last answer, which you might have stored. Usually you can pull back the very last answer you just got, so you don't have to store this 31 number, at least not necessarily. You could, but it won't. For most of you, it won't be necessary. And then we come up with B is about 38.942 degrees. Okay. So after finding C, we could have found B first using the law of sines and then found A using subtraction from 180. The answers won't change. It's just a choice that you have as to which one you want to find first. Okay, so next example. Solve the triangle ABC if A is 9.47 feet, B is 15.9 feet, and I don't know if they'll do this to you, but it just occurred to me that one of these measures could be given in a different unit of measure. Like they could have said 306 inches or something instead of 21.1 feet. And you'd have to make a decision about whether you want to convert everything to feet or everything to inches in that case, because the units have to be the same unit of measure. So if they mess that up on you and give you a mixture of measurement units, you're going to have to convert so that they're all in the same one. Wouldn't matter which one you chose, but you'd have to have them all the same. Okay, so which angle is potentially obtuse? Well, evidently C is the longest side, so angle C. So let's use the law of cosines. Since it's side, 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 that's going to be our go-to, just like it is for side angle side. So the side that's longest by itself squared equals the sum of the squares of the other two given sides minus twice the product of those two sides that were given multiplied by the cosine of the angle that has the same name as the side by itself on the other side of the equal sign, so C. So, since we just did this same kind of thing a minute ago, I'm going to rocket my way through here. To get cosine of C by itself, I'm going to take the 21.1 squared, what's on the left, subtract the two things that are added together. Again, if you're doing this in your calculator, you're probably going to want to put that in its own set of parentheses. And then divide that by the numbers that are multiplied by the cosine. And I'm actually okay if you skip to this like I did. And you don't have to write as many steps as I did the first time we did that. I just don't think that's necessary. And so C will be cosine inverse of that mess. And it's now in calculator ready form. Of course, you have to have good knowledge about the calculator, like protecting the numerator and denominator with its own, which each having its own set of parentheses, is something that you probably want to know, because otherwise you might mistype and get the wrong answer. Okay, so type that in your calculator, and for C, you should get 109.944 degrees. Okay. So it doesn't matter if I find B or A next, so I think I'll go for B. So the sine of B over the value of B as a length, 15.9, should equal the sine of C, which I forgot to write that you should store this, but hopefully by now you've made that a habit, because there are a lot of calculations when you're solving a triangle. You have this to do, then that to do, then that to do. So you realize that perhaps you might need these numbers again. So it's a good idea to store things as you get them. And that was angle C, so I need to put the length of C under it. So 21.1. Okay, so the sine of B will be obtained by multiplying both sides by 15.9. And then find B using sine inverse. And the good news is that the largest angle, C, was found, so it's impossible for any of the smaller angles to be obtuse. So using the law of sines to find those that are definitely acute, because obviously if C is obtuse, the others have to be acute, is perfectly valid. And this is a lot less work and a lot less complicated than if you'd use the law cosines again. Not to say that that would be an invalid result. If you did that, it's just a lot more work for the same answer. Okay, so that tells us that B is approximately 45.102 degrees. And then, of course, we'll find A using the fact that the three add up to 180 degrees. So we'll bring back the 109.944 by recalling it from memory of our calculators, and also subtracting the latest answer we just got. It's still in our calculators, the 45-degree number. All right, so that means that A is approximately 24.955. All right. Okay, so now we've got a word problem. So let me go over here. And work on this. So it says find angle B. You know what? I think I just remembered that I didn't follow the directions 2 problems ago. And you may have thought about that when I was going through it. And you may have thought, hey, wait, you didn't follow the directions. Good for you if you noticed that. This was the triangle that was given side, side, side with 5, 6, and 9. Read the directions for that one again. What did it say our answer needed to be once we finished? Yeah, each of them was supposed to be rounded to the nearest 10th of a degree. So that's okay, as long as you go back and read the directions and carefully make sure you've done everything you're supposed to. You're okay with having the 3, better too much than too little. And if they say to round to fewer places, you should be able to do that without any loss of composure or accuracy or anything like that. Okay. Now, this brings up a point if on My Math Lab, when you're doing problems of this type, if it says to round a certain way and you don't, like if for this one it was a problem on my math lab and the directions had said round to the nearest tenth, and I had typed in 109.471 degrees for C, they would have said that's wrong. Not because it's the wrong number, it's because I haven't rounded correctly. And they won't tell you that it's a rounding error. So please make sure you're reading the directions, because there's really no other way to know what you're messing up. Because it could be that you have the right number in front of you, you just have rounded it incorrectly. So something to be aware of. So sorry I had to stop and go back, but I guess it's better to see that I make mistakes sometimes too. Anyway, they have a roof that looks like this. It's really steep on one side and not so steep on the other, and I guess this really happens. Like I know my house, that happens. Anyway, this is kind of a construction type problem, if you will. Okay, so we're going to call this B, A, and C just to have convenient labels. We need to decide on some convention. And they actually give us a picture. They don't list the information. They just give a picture of it, which is kind of realistic. I mean, if you were doing this in a home project of some sort, maybe not a truss, maybe you're not up to doing that much work on your own. But if you're doing some kind of home project, you probably won't have a list of numbers. Well, you might, but you might have a drawing that you've made of what you're trying to do and label things just like this. So it's not out of the ordinary. All right, so they do say that we're trying to find B to the nearest degree. So that's that nearest degree that I was reading a moment ago before I said anything and realized I hadn't rounded to the nearest tenth of a degree in that earlier problem. So, and by the way, this is another reason why you want to make sure you write down your work, maybe in a spiral that you keep of all your homework problems, so that you have them to look at when you're studying. But also that if you think you've gotten it right and you've got the work there, you can go, oh, wait, they said to the nearest tenth, and you can easily go back, look at your answers and round appropriately, like I just did. All right, so they're asking us to find angle B. We're not solving the whole triangle. All we have to know is this. And so it's really a lot of work to solve for everything, and if I don't ask you to, please don't, because you won't have time on the test to do a bunch of extra stuff that nobody asked you to find. Just a word to the wise. All right, so since it's angle B we want, that means side B across from it is by itself. And I know I'm not finding the largest one first because I don't need that one. I only need angle B. So it would be silly to do A first in this case because we don't need A. If they're having to solve the whole thing, I would find A first because it's potentially obtuse, but that's not the problem. And this will be cosine of the angle opposite 6 feet, which is angle B, of course. So isolate the cosine of B by taking 6 squared and subtracting 9 squared from both sides, subtracting 11 squared from both sides, and then dividing both sides by the product of negative 2 times 9 times 11. And so B will be cosine inverse of that mess. And quite honestly, some of these numbers are really easy. So if I were typing this, when I'm typing this in, I'll probably type 36 minus 81 minus 121. Not what I see, but what I can do in my head. Divided by negative 2 times 9 times 11. And if you don't feel like you want to do that arithmetic in your head, don't. Type what you see. Except, remember, you will have to have the parentheses to protect the numerator and the parentheses to protect the denominator. And if you're not getting the right answer, that's usually what people are doing wrong. The only other thing that people sometimes do wrong is they're in radian mode for some reason, and they should have been in degree mode for all of our triangle problems. So you should get 33.030 degrees. And then for your final answer, pay attention to the directions. To the nearest degree is going to be 33 degrees. All right. So here's a next page is kind of a nice summary of the cases that we started this with and some suggested procedures. So if you're given side angle angle or angle side angle, obviously when you're given two angles, the first thing you do is find the third angle, and then you could use the law of sines to find all of the sides, or the sides you don't know. For side angle, this is that ambiguous case. It's the one that makes an ass out of you, a donkey out of you. I may have said that kind of joking way. The SSA or ASS form is the one where you have to draw a good picture, think about what's possible with your picture, go through that if A is shorter than B and all that stuff that the picture helps you decide. And you compare in that one case where the angle is acute and the side opposite it is shorter than the other side that's given. That's the one that could be 0, 1, or 2 triangles. And so you have to figure out, which one it is by comparing the opposite side of the angle given to h, the altitude. Remember how, go back and, if you need to, go back and figure out how to find that altitude. And figure out if you have no triangle, one right triangle, or 2 oblique triangles. And then if you have 2 oblique, you have to solve both of them. So make sure you go back and review all the things we talked about earlier. I'm not going to rehash them completely. I'm just trying to remind you of them. Okay. If you had side angle side, that's one of the 2 major ones that is going to use law of cosines first, and that'll find that third side. Then you can use the law of sines to find the smaller of the 2 remaining angles, just to be on the safe side. You don't want to potentially be finding what's supposed to be obtuse with the law of sines. So always find the smaller of the 2 remaining ones, which will be opposite the smallest side, and then use the angle sum formula to find the remaining angle. And then side, use the law of cosines to find the largest angle, then use the law of sines to find either of the remaining ones, and then use the fact that they sum to 180 degrees to find the third angle. Okay, so that's the end of solving triangles. The only remaining topic in this section is how to find the area of a triangle. Well, you may think, well, yeah, duh, I know. Area of a triangle is 1/2 base times height. Well, yeah, of course. If you're given the base and you're given the height, you can certainly use that formula. And if you're given a right triangle, by the way, if this is a right triangle, then the smartest thing to do, because you could draw an altitude from any vertex of this triangle, the best way to do a right triangle is to call one of the legs the base and the other leg the height. And don't do this and try to find the height. That's like a waste of your time. If it's a right triangle, they're perpendicular. So if one of the legs is your base, the other leg has to be the height of the triangle because the base and the height are perpendicular to each other. And use 1/2 base times height. So 1/2 leg times leg in a right triangle situation. Or if they just happen to give you the base and the height, yay, go for it. Use that formula. But what if they give you side? How are you going to find the area of that triangle? Well, this is something that we call Heron's formula. In some books it's called Hero's formula. This book calls it Heron's, which is just fine. The Heron's formula involves first finding something called the semi-perimeter. You know how to find the perimeter of a triangle, right? If the sides are A and B and C, the perimeter is A plus B plus C, right? You just add up the three sides. That's the perimeter. And what does the prefix semi mean? It means half of, like semicircle. So you're going to find the perimeter and then divide it by 2. Half of the perimeter. That's the semi-perimeter, and we're going to call that S. Okay? So that's a formula that you're going to need to commit to memory for the semi-perimeter. It's not like it's hard, but you do have to know how to find the semi-perimeter. Add up the three sides and divide by 2. Okay, then to find the area of the triangle, this is the formula that you use. It will be the square root of the semi-perimeter times the semi-perimeter minus A, one of the sides that you know, times the semi-perimeter minus B, another one you know, times the semi-perimeter minus C, the third one you know. So you actually end up doing all three of them subtracted from S in that formula, multiplied together times S, and that will be the area of the triangle. So that is a formula that you'll use when side, side, side is given to find the area of that triangle. And it's a two-part formula. You have to find the semi-perimeter S, and then S goes into this formula. Okay. So let's do a problem. It says the distance as the crow flies from Los Angeles to New York is, you know what that means, as the crow flies. It means if you're not going on roads that aren't straight, as the crow flies, as you go straight from one city to the other. No detours, no weird highway intersections, nothing. We're just pretending like that's a straight distance from LA to New York. And they say that that's 2,451 miles. From New York to Montreal, let's say Montreal is about right there, is a distance of 331 miles, again as the crow flies. And from Montreal to Los Angeles, and by the way, if you didn't draw this to scale, which I didn't do, it's no big deal. You want the relative lengths to look sort of right. You don't want for 2,000 something to look shorter than 300. But obviously it's not drawn to scale, and don't worry about that. It's more about getting your thinking straight than anything else. Okay. And the question is, what is the area of this triangular region? Now, if reality kicks in, that triangle is actually on the surface of a sphere. And so what we're about to find is actually not correct. It's as if you were on a flat surface. If the Earth were flat, the area of the triangle. This will not take into account the curvature of the Earth. So we do a lot of simplifications like that so that we can do problems. But I'm telling you this, the area of the surface of a sphere and this triangular part on it would not be exactly the same as if it were on a flat surface. So the directions say ignore the curvature of the Earth. Okay, well, that's what we're going to do. Okay, since this is side, 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 I'm going to find the semi-perimeter first. So 2,451 plus 331 plus 2,427 is the perimeter, and divide by 2 to get the semi-perimeter. And especially if this is a bunch of weird numbers, you should probably store this in your calculator because you don't want to have to retype that. Okay, so store that in your calculator. And by the way, when I'm grading a test, this would be a stopping point where I would check to see, do they have this right? Because if you don't have this right, you can't get the right answer. So that'd be a stopping point for me to check and give you some partial credit. If, let's say you got that far but then messed up the rest, you could still get some of the credit. All right. So the numbers that I'll put in here, because I've got to record what it is I'm doing, will be S under the radical S times S minus, just pick one of them, doesn't matter which one you do first, because you're going to end up doing all three, times S minus another one, times S minus the last one. And make sure that your vinculum goes all the way to the end of your radicand. All right, so that area is approximately 401,664.111. Now, does it say that we need to round to a certain thing? No. Because it's a word problem, you might want to answer in a sentence, which is always a good idea with a word problem. And if you do that, the area of the triangle is about, and at that point you could decide that you want to round using different rules from what I've told you to do. You may want to go to the nearest unit. You might want to round to the nearest 1,000 even. I mean, it's kind of up to you, because I can look at the number you have up here and be satisfied that you knew what you were doing and got the answer right. So I'm going to round to the nearest unit, nearest whole number. But if you decided to round to something different, like the nearest 10, the nearest 100, the nearest 1,000, that's fine. Now, the big question for me is, are we done with that problem? No, we don't have units. And if the distances are in miles, what would area be? Well, if you think of a rectangle, length times width, you're going to be multiplying miles times miles, and that's going to be square miles. Square miles. Okay, so make sure you have the correct units on that, square miles. That's part of the answer, and I will grade if you have the correct units or not. All right. So that finishes that one. Now, what if you're given side angle side? By the way, both of these are the ones that use law of cosines, so that may be a way to remember them, is the two that use law of cosines to solve the triangle. We use different things for finding their areas. Okay, so side angle side is given. These are the formulas. Again, I would memorize actually just one of these and remember the relationship. It's 1/2. Oh, that A, maybe I should write area instead of A, because A makes you think I'm doing angle A, and I don't want to give that perception that that's angle A. So I'm going to write the word area just to be safe. The area formula is 1/2 times the side that's given, let's call it A, times another side that's given, let's call that B, times the sine of the angle between them. If you think about it, if this is A and this is B, then this is side C, and that makes this angle C. So that would be the sine of C. So you end up using all three letters. And in side angle side, those are the two sides that are given and the angle between them, which uses all three letters. So this formula could be written 1/2 BC sine A. Notice all three letters are used. It could also be written as 1/2 AC sine B. So I wouldn't memorize three versions of this because, well, it loses validity if I don't call it triangle ABC. Then you can't use the formula at all if that's all you know. And memorizing one of them really gets whatever the things are called. It's going to be 1/2 times the product of the two given sides times the sine of the angle between them. And if that's what you know, you don't have to memorize a formula for every different combination of letters that might be used in naming a triangle. Okay, so let's do an example. We're asked to find the area of a triangle ABC that's shown. So let me draw that. I think I gave it to you in the notes, but just in case I didn't, this is sort of what it looks like. Angle A, angle C, angle B. Angle B is given to be 55.0 degrees. And side C is 42.0 feet. And side A is 34.0 feet. Okay, so the area, since side angle side is what's given, we can use one of the formulas above. It's going to be 1/2 times one of the given sides times the length of the other given side times the sine of the angle between them. Okay, and just punch that in your calculator and see what you get. I get 584.875. Then look at the directions. Does it give you any indications about rounding? It doesn't, so we'll use three numbers after the decimal point. And are we done? Nope, we don't have units. Since the lengths were in feet, the area will be in square feet. What if it were volume? Yeah, it would be cubic feet if it were volume. So it's something you probably should just know is the area should always be square units of distance, and volume should be cubed units of distance. All right, very good. So here's our last example. Find the area of triangle ABC if angle A is 24 degrees, 40 minutes. Side B is 27.3 centimeters. And angle C is 52 degrees, 40 minutes. Okay, well, I don't have side, side, side. I don't have side, angle, side. What I have is angle, side, angle. So what are we going to do for this? Well, we're going to have to either find all three sides and use Heron's formula, or we're going to have to know two sides and an included angle and use the formula we just talked about. So it's kind of up to us what we want to do. Since angle B is not given, but the other two are, angle B is actually very easy to find. So I think that's what I'm tempted to do. And when you do that subtraction, you should get 102 degrees, 40 minutes. And that was an easy thing, so I just kind of did it without really thinking about my strategy for this problem more long term. Let's see. Well, if I'm going to use Heron's formula, I have to find two more sides. So basically I have to solve the whole triangle. Or if I use the formula I just got, I only need one more side. So do we want to find two sides or one side? I'm thinking finding one more side is worth it. And the good news about having found B is that I needed a pair, B and B, side B and angle B, to be able to use the law of sines. So it doesn't really matter to me if we use A or C here. It just doesn't matter. So I'm going to say that A over the sine of A, I could have gone for C instead, just acknowledging that, would equal B 27.3 divided by the sine of angle B, which we just calculated. And to solve for A, we'll multiply both sides by the sine of 24 degrees, 40 minutes. And then typing that in the calculator, we get that A is about 11.678. And just in case I need that again, I'm going to store that in my calculator. Okay, so now that I know A, the area, because we already know B, the area is going to be 1/2 of A, which is a number stored in your calculator. You're not typing 11.678, right? Times B, which is a given 27.3, times the sine of the angle between A and B. Or in other words, what letter have I not used yet? Because in the formula, if you look back at that formula, in every version of it, you use A, B, and C, or B, C, and A, or A, C, and B. You use all three letters. So I've used A for the first number, B for the second number in parentheses. So I have to use C. And what angle it was, C. Go back up here a little bit so we can see it. That will be the angle that we take the sine of. Okay, and that'll give us the area. So the area, when you type that in your calculator, you should get 126.741. Any directions about rounding? Nope. So it's our choice. So we're going to use three numbers after the decimal point. And now, are there any units? Yes. Lengths were measured in centimeters, so this area is in square centimeters. Okay, and that's it. That is the end of this lesson. I will see you in class.